And yes, it's just chatter. So there's no, other than saying hello interwebs and welcome to another I'm with Stargate Genius. This one I'm really excited about because I got Erik. I got Erik
Yeah,
from The Simpsons.
but who's the genius?
Well, not me, that's for sure. That's your job, Erik. You're up for
Okay,
that.
thank you.
So Erik, if you wouldn't mind, do you want to let people know who you are, what you do, before we get into how you do it and how you got there?
Do you want the whole story?
Sure, why not?
Well,
However much energy you've got.
Loads of energy. Well, at the start of the chat, yes.
Yes, yeah.
No, Erik. Well, you already said my name. I'm a project scientist at ESA, European Space Agency.
Yeah.
Not to, how do you say that? I mean, it's the European side of
Right.
the agency, of the space agencies.
Yeah.
And I'm trying to, I'm working with one of the satellites, which is looking upwards in the sky and making and trying to make as much science as possible, and trying to keep all astronomers happy
Good luck.
in the universe. Yes,
Which satellite are you working with right now?
that's called XMM Newton. XMM is X-ray multi-mirror, so it has different X-ray mirrors which can focus X-rays. And Newton was a famous physicist.
Yeah, it's about time you got a satellite.
Yeah, a little bit late.
Yeah, I feel like he deserves at least a few of them, doesn't he? I mean,
Yeah, he's yeah. I mean, I think he's for a long time he's dead now. So yeah, he
what?
can't get it anymore. Yeah.
But your interest is in you've got a real focus on the X-ray stuff, don't you? The X-rays are a big part of what you do.
I mean, yeah, no. Well, when I started when I was young, I started astronomy in the
Oh yeah, okay.
optical observations and analyzed optical observations
Mm,
of variable stars.
mm.
But then when I started my PhD, I had to go into X-ray observations. So,
You sound begrudging. You sound like you didn't want to do that.
well, there was a post available, and then you say yes, and then you change just wavelength. And then 20 years later, actually from 2000, somewhere around 2000, and now it's 25 years after,
Wow.
I'm still looking at X-rays, gamma rays. It's all like exotic, the high energy universe,
But
black
you
hole.
get and what is so for pretend scientists like me, what is the advantage to optical? What is the advantage to X-ray and then gamma ray? What is the advantage to using these different sort of wavelengths?
So it pretend scientist.
Pretend
Well,
scientist, yeah, yeah. You can have a real science answer, but I'm a pretend scientist. That's the way.
yeah,
Yeah,
well, so you can pretend. Okay.
yeah, yeah. I'll
Now the
pretend to
optic
understand.
best, yes. No, the optical is of course with your eyes. I mean, that's the optical wavelength. Infrared is what we sort of feel as warmth.
Mm,
And when you go the other way, UV is what the sun brings us, and what you should not, what you should avoid,
right,
basically,
right.
sunburned. And then if you go more extreme, then you go into X-rays. It's more. I mean, what we observe is a little bit more extreme than what you do if you get an X-ray of your chest, for example. I mean, these are what I would call lower energy photons, which try to map your bones, for example.
Erik,
But
do you still have the voice cancellation on?
no,
No? Okay, all right. I'm losing the beginning of some of your sentences. I don't know whether it's just the microphone or what, but I don't want to
uh,
miss any of
no.
this magic.
Well, maybe maybe it's my voice.
That's good. I mean, it sounds good now. So
Yeah.
maybe it's just the yeah.
Well, maybe I should shout more. I can talk Dutch if you want.
Yeah, that'll be
I mean,
great for me. That'll make it even more easy for me to understand. That's perfect.
gibberish. How do you call it? Dutch gibberish. Yeah.
I was getting used to it though. I was getting there. I mean, I'm not sure I could say anything in Dutch, having been there for a week, but
Yeah. Well, it was great to be there. Yeah. Right.
oh, fantastic! Yeah, I mean, it was just I'm completely smitten. Like and where you're working, ESA is just amazing. I mean, all right, so go
Well,
back. So optical,
yeah.
you're looking at things, you're using your eyes. You've got, I guess, some more traditional camera lens type of approaches to this stuff. Would that be fair to say?
Uh, for the optical, yes, or for the infrared, yes. UV, yes. But
Mm,
if space is a little bit more difficult to focus them. So
right.
you really specific equipment or specific telescope to focus the X-rays.
How do you focus X-rays?
Yeah, that's a good one. I mean, um, yeah, that's a good question. My God, you should have sent me all these questions beforehand.
I just thought of it. Well, I
I'm
just like, is it a lens thing or is it a magnetic thing? I mean,
not.
what's the
Oh, no, it's still lensing,
hmm.
but in a particular way. You need. I mean, normally, if you would have an optical lens and you shoot rays on that lens, they just go through.
Hmm.
X-ray telescopes, you need certain shells, and rays need to be reflected. I mean, if you go to higher energies, I mean, X-rays and gamma rays, most of the time they go through material. I mean, like your body, but not your bones. Or also, I think your bones. But um, in X-rays and low energy gamma rays, you need to have certain angles to reflect them, and only then can you focus them.
Oh,
So,
wow. So how complicated are these satellites then?
oh, they are very complicated. I mean, you need to put the shells where you focus, where you reflect your X-rays on. You need to position them at this in a certain way so that they can reflect the X-rays. I mean, if you would position them like this, they may go through or they reflect to another direction. But if they are at a specific angle, you can try to focus them. Yeah, it's difficult uh, to explain this in.
No, that gets a sense of
Yeah,
it. I
yeah,
didn't
yeah.
even realize I didn't realize you were reflecting them. Like I mean, the
No,
X-rays seem like something completely different to me. But of course, as you say, they're just another wavelength, aren't they?
no. Also in a lens, you reflect optical light uh, or you focus optical light, but that's easier because the angles you're talking about are bigger and it's easier to focus them. But for X-rays, it's quite difficult. And if you go to gamma rays, I mean, there are also a lot of sources in the sky emitting even even more complicated. Yeah.
Wow. And how long have we had these? Like, how long have we been able to put things in space that have like access to like X-ray scanning and
Uh,
gamma?
um, well, basically already I think from the early 20th century, I would say.
Wow.
Oh,
Okay.
yeah, 20th centuries after 1900, right? Yeah.
Yeah. Yeah. Yeah. That makes sense. Yeah.
Uh,
Uh,
no, but first, I mean, first detectors were like Geiger counters. I mean, they just you have a gas reservoir, and when an X-ray comes in, you can produce light, or you can produce a lot of electrons, and you can count your number of electrons or the amount of light. But later on, they started to develop systems where you can really focus the rays, and then you can also make images. Because if you have a Geiger counter and you just count X-rays, then there is no real imaging possible.
huh. And you said you started with optical, so the appeal to optical was just that you could literally just look and see this stuff and examine it with your own eyes without any extra sort of fancy tech?
Well, not with my own eyes, but I used telescopes. For example, the one
Yes.
in Chile.
Got me. Yeah.
Yeah. Yeah, we used big telescopes. I mean, professional astronomers, they use big telescopes ranging from, let's say, lenses with 50 centimeters to a few meters.
How big can you make them? Because at some point, surely they
Yeah,
fall apart, right? I mean,
exactly. I think the ones, I mean, probably the ones at the in Chile, they're probably the biggest. I wouldn't know. I mean, I'm out of optical astronomy now for more than 25 years, so
do
I
you miss
can.
it though? Do you miss it at all? I get the sense you miss it a bit.
Um, I mean, it's nice. Well, nowadays, when you do optical observing, most of the time it's just sitting behind a computer, and there is somebody at the remote observatory basically pushing the buttons, or sometimes you push the buttons, but just on your laptop. But in the early days, it was more like going to the observatory. I mean, you have the long trip to the observatory. You go to more than 2 kilometers or 3 kilometers from the sea level, which for a Dutch person is very high.
You're not
I
used to any kind of. There's no bumps.
mean, no. I mean, I live below sea level, so um, and then you are at this observatory. I mean, it's really amazing. And sometimes you are above the clouds when it's cloudy downstairs. It's yeah, it's very very remote. And then when you are observing at night and you go outside, I mean, you can see the whole sky, very bright, and it's very quiet, and it has some kind of atmosphere when you do the actual observations at an observatory. And you can't do it with X-rays or gamma rays or even with UV.
There is
I
something magical about it, isn't there? The idea of just like a dark night, bright sky,
Yeah,
bright stars, and a massive piece of glass to see it all
yeah,
better.
yeah. Well, I think I lied because I mean astronauts. I mean they are able to go outside the atmosphere, Earth atmosphere, and they can sort of point any X-ray instrument or gamma ray instrument towards the sky, but still they won't see it sort of live. They have to reduce the data and see it somewhere on the screen. But that's the closest being in a kind of observatory, I would say. Yeah.
So when you first started, how did you first get into this? Like, what was the impetus to get into this area of science?
I guess as a young child, you are interested in astronomy, or you see some. I mean, of course, I'm a better person, so you're sort of interested in the physical world, and then you get into you see magazines of nice pictures, and then I was also I knew some people at the amateur observatory. I was helping there, and I bought books and
I've
and
well, I've never heard of that. So wait a second. So there's an amateur observatory, like so there was space nerds out there with telescopes, and you got to help
oh
out.
yeah, there was somebody uh, um, in the outskirts. In Holland, there are no outskirts. So there was somebody who had a small observatory, and they had open days, and then people could come in and have a look. And then I had on display all my stuff, my books and so forth. But at some point, I knew you could study astronomy, and I said I want to do that, and I did it, and that's how I
Was there a background in science in your family? Were your family scientists or anything?
are into teaching, and I don't want to teach.
No, because there's people involved.
I mean, yeah, I mean, there's an audience, and then you have to talk to people. That's awful.
That sounds terrible, Eric.
Yeah. all the teachers who are listening. But no,
No, it's definitely it's a totally different skill, I
yeah,
think. And the funny thing is you do teach in a way because you've done these chats, you've done these panels and stuff. Like you
yeah.
obviously do like doing the outreach as well.
I mean, of course, you give presentations at conferences and so forth. So there are always audiences involved in the work, but it's at least it's not every day, and I can choose my holidays.
Did you when you started, did you see it as a solitary profession?
Wow, what a question! No,
You
I
did you
uh,
realized there was going to be structures and people around you and you know.
never thought about it. I must say. I mean, of
I
course,
just remember as a
when
kid, I remember as a kid myself thinking that to be an astronomer was like you are alone, you're in the middle of nowhere, you got the massive satellite, and then of course aliens attack. But you know,
uh, yes, if they come from Mars and green, then you have to be careful. Yes, because that's close by. No, but to be honest, no, I never thought about it. Um, and when you start studying astronomy, there are more people doing it. I mean, not a lot, but still. And then you go into your research and doing your PhD. It's always involving teamwork. I mean, and even now, you're alone.
it's something that came up actually in our talk, which I thought was fascinating. And something that I took away from ESA Open Day this year was just as someone as an observer on the outside, you think of scientists as these sort of individuals, you know, working against, struggling against society to make these discoveries. And the reality is, it's a community. There's these communities, and there's people coming in from all different angles and
Oh,
stuff. It's amazing.
and it's universal. I mean, you talk to people from Japan, you talk to people from the US, Europe. I mean, especially the European Space Agency. It's a community of all the member states. So you're constantly talking to different people. I mean, I know many languages, but not as many as European countries there are. So
It's
it's
funny.
yeah,
Someone was saying how, oh my God, they speak 10 languages. They're brilliant. They go, or European.
yeah,
Because
exactly.
North Americans just have no concept of that.
No, it's only American English.
Yeah,
Yeah.
yeah, that's it. Well, it's American or British English, basically. You know,
There are Canadian English.
there is, I guess there is, but it's just French, basically. There's a French angle to it. You know,
Yeah. Oh, okay. You just have an accent then.
yeah, and it's not a very nice one too. Our French Canadian accent is it's very sort of like this. It's very sort of yeah. Even the Parisian, well, I was gonna say the French laugh at
Yeah.
us too. So you know,
Yeah.
yeah, Canadian French Canadian, exactly. Yeah. Okay, so you're studying astronomy, did you right away know there was a specific part of astronomy you wanted to get into, or that's something you discovered on your during your education? How did you know where to
Uh,
go with it?
well, when I was, they call it high school, I think. So after your, yeah, then I knew I just wanted to study astronomy. So the first years is physics and mathematics, and then you slowly getting when you have to do your research and write your reports, then you go into certain directions. It depends on the university where you are. And at the University of Amsterdam, it was more into double stars, exotic stars, black holes, neutron stars, that kind of thing.
Well, and okay, first off, I just have to say the idea of going to university in Amsterdam is the coolest thing ever. Having been to Amsterdam, I'm amazed you weren't run over by bicycles.
But that can be similarly in Utrecht, Groningen, Nijmegen as well. So I mean, the whole Dutch country has bikes.
It's
So
dangerous everywhere, basically.
so of Amsterdam is not the most dangerous place. Yes.
I couldn't get over the traffic patterns, like how people somehow managed to independently decide when people were going to go. Like it just seemed so random to me.
Oh, you have to be. I mean, as a cycle, if you're on a bicycle, it's fine. I mean, if you're not on a bicycle, if you're in a car or walking, then it's can be dangerous. I mean,
Yeah,
it's
there's
like
definitely like a tier system. I feel like the top of the food chain are the cyclists.
yes, It's different from Japan, for example. There, the people on the paveway are the top of the food chain.
That's us here too. We're definitely the pedestrians atop the food chain
Yeah,
here.
yeah,
Yeah.
yes.
In fact, here there's a risk that you'll be run over by a pedestrian while you're in a car.
Oh, and who is liable then?
That would be you in the car.
Damn.
Yeah.
Yeah.
Yeah. Okay, so sorry, I distracted.
Yeah.
So
Yeah.
we're at Amsterdam. We're studying astronomy. We're studying now. Why the specific? Why did they go to black holes and twin stars? What's the appeal there?
It's just where the professors were. I mean, of course, every university has its niche basically, and in the University of Amsterdam, you happen to have the niche of they call it X-ray binary research.
That's a hell of a niche.
Uh, uh, yeah, for you it may be hell of a niche. Yes,
Right.
in the subject for a long time. It's just yeah.
And so okay? So could you attempt to explain that to this little tiny brain? So you've got twin stars. I'm assuming they're interacting somehow,
Yeah.
and why would that then relate to black holes?
Well, there are many twin stars. I think there are even many triples, and there are even quadruples. But what it relates to, what we call X-ray binaries, is that black holes, um, they attract they attract matter.
Everything, right? Light,
Yeah,
even light. Yeah, yeah.
yeah. The gravity is so strong that they can interact with their close neighbor, and then they even suck material from the neighbor. And when they eat it up, they they radiate the result into this exotic radiation, like X-rays and gamma rays.
But okay, so the idea that these black holes are radiating something is weird to me. That the Hawking's thing? Was that the Hawking's radiation thing?
No, no, it's even well, actually, it's before it gets into the black hole. So when it goes from first of all, they need to be close enough together so that the gravity of the black hole is strong enough to pull material off. But it doesn't fall directly into the black hole because they rotate around each other. So it goes first into some kind of spiral, closer and closer and closer to the black hole, and it gets more and more energetic. And when it gets more energetic, it starts to radiate first in the optical, and then when it gets close to the black hole, it gets more extreme, more energetic. And then when it's close to the black hole, it radiates in X-rays and gamma rays. And when it sucks into the black hole, there is nothing anymore. I mean, no radiation, basically. But
Wow. God, they
what
are
you
they are the things that, and you can see why they're used. Like, I mean, I remember going to see Black Hole the movie
can't
when I was a
see,
kid.
you can't see them. They're black.
The concept of them in my
Oh, okay.
head is
Yeah.
just so, I mean, it's so perfect for science fiction because it's
No,
just it's a hole that we don't know where it goes type thing, right? I mean, that's
no,
yeah.
no, nobody knows where it goes to. I mean, it's more a mathematical thing. No, I mean, is there another universe? Does it go to a white hole? There are these theories. We will
What?
never know, because once we go there, I mean, we already torn apart when we are close to the black hole. But once we are in the black hole, we cannot communicate anymore with with the with our world. We can communicate with somebody else
So
or
their
some.
only way to really know what's happening is going to be mathematically. We're going to have to like model these things rather than try to get into
Yeah.
them ourselves.
Well, I mean, you mentioned Hawking radiation, which I cannot explain. I'm not a theoretician. I cannot explain in great detail, but that's something which may convey information from within a black hole back to our world.
Wow. Okay. Right.
But that's again theory. I mean, we haven't proved that it exists. I mean, it's
So you're definitely you are this is practical stuff. This is the physical. These are things that you are dealing with what you can see and what you can measure,
yeah.
not the sort of abstract side of this stuff.
No, I'm not genius enough to do the theory.
Here's okay,
I'm
here's
just
something. Here's an
I'm,
inside thing for I see
I'm
for
just
this.
counting. Yeah, just counting X-rays.
So this is what I found so funny about everybody at ESA and most of the people that I speak to is the more intelligent you are, the less intelligent you think you are. Like it's so bizarre. Like it's so funny. People are like, "Oh, I don't do the really difficult science. I just, whatever."
Well, I mean, so maybe okay. I am counting X-rays, but I do some interpretation, and sometimes you use the theoretical models to prove that what you see is indeed what they predict. So in a way, but I don't do all the calculations, the theoretical
So
calculations.
you can be the dream killer basically, where you can go like, "Yep, data doesn't support that," or you can go like, "Yep, thumbs up, data looks
Yes,
good."
yes,
Yeah.
exactly. I mean, we can kill models, or we can approve models and make people happy or make people cry.
Did you ever want to do the theoretical side of stuff? Did that ever
No,
interest you at all? No, it was
uh,
always yeah.
uh, that's a good question. I don't think so. No, that's more. Um, yeah, I mean, programming stuff, and I like to have I just like to count the X-rays, do the interpretation, and fiddle with it and make the best out of it.
Are you hands-on? Do you like are
Yes,
you are
yeah,
you a
yeah.
you
I'm
like
more.
getting into the electronics and all the mechanics of it all?
Uh, I mean, then you go into the engineering part. I mean, I think it's best to be the dreamy astronomer looking at the sky. Well, not in the optical, but then in X-rays, and yeah, dreaming about black holes and that stuff. But if you go, well, I mean, yeah, but doing the theoretical modeling, I mean, that's more. Well, it's not fake, of course, but it's more predicting things rather than doing the real observations. And it's also nice to compare it with observations done in the optical or other wavelengths. So I mean that that's basically, yeah, the
I would
dreamy.
yeah, I would agree. My
Yeah.
interest is always in more in the kind of the what we can do now. I'm not good at sitting back and just thinking
No.
about things. I like
What you see, that's, yeah.
what was that?
What you see is what you get.
Yeah, well, I mean, again, to me, that feels like
Yeah.
the type of science that I
Yeah.
prefer. But that said, I've talked to like pure mathematicians as well, and I mean, it's
Oh
amazing what
yeah.
they're doing.
Of course. I mean, they can do. I mean, for example, a couple of years ago, they predicted how a black hole would look like, or if you're close to the black hole, so the environment around it. And they well, they did the observations. I mean, it took a long time to set it up and to conduct them and do the analysis. But in the end, they could match what they predicted. So it's also cool if you can predict something and then it is reality.
That
So yeah,
that was always the appeal to me. I loved the idea that you could figure out if I threw something where it was going to land. That seemed somehow there was a
yes,
magical quality to that.
I agree. And I'm basically on the one hand showing you right or you're wrong. Go back home and redo your calculations, or you're good to go, and now do the other thing.
When you do, so when you're looking at this, when you're looking at like gamma rays or X rays, the non-optical side of stuff, are you literally just working with numbers, or do you create, what kind of models do you create for this or with this stuff?
Well, basically, as I said, it's counting. Well, in X-rays and gamma rays, you can still count them more or less, and that's what you do. You count them as a function of wavelength, and try to model it and see what kind of radiation it is and how the radiation comes along, and that's
Do you
basically.
do you need a lot
And,
of technology for this? I mean, is this like, or is there data there that you can look at yourself? I mean, can people do this like at an amateur level?
yes, of course. Yeah, I mean there are archives with loads of data to be taken, and yeah, I mean I can send you some X-ray photons as a function of time, and you can do your analysis. You can see if it's variable. You can see if it's very energetic or not, or these kind of things. Yeah, no, and the tools are available for the public.
Was that always the case? Is that a new thing, or was that when you started? Was that still basically public domain stuff?
Um, well, people tend to put nowadays. People tend to put things into archives, and of course the internet also helps. I mean, you need to have access. I mean, in the early days, things were put on a disk or on a tape drive, and then you had to go to the observatory and then take it home, and then to read it in, and etc. etc. Now it's just you connect to a machine somewhere in Alaska or whatever, and you download your data, and then you start to immediately your analysis, even during the observation itself. I mean that's maybe what has changed, but I think access to the data has always been possible, and archives were always more or less there. I mean, but from data from the early days, like the 60s or 70s, I mean, these are more difficult to find because,
Which you've been playing with too, right?
yes, I mean, most of the stuff was either put on the early days was, for example, tape drives, and tapes deteriorate, so you cannot read them anymore, or
Tape
they
is a
were.
nightmare. Tape, as an IT, I did IT for a couple of
Yeah,
years, and I hate tape.
and some data were put on paper, and when you move institute or something burn, I mean, when there is a fire or you move the whole institute moves, I mean, you get rid of the paper, and then the data are gone.
See, that
So,
terrifies me because we live in a world that's all digital. What if there is some kind of cataclysmic digital event? We've
oh,
got everything's digital.
well, that's probably why we have the cloud. I mean, data are
The
back.
cloud is just computers on someone else's house, right? Isn't it? I mean, like
Yeah,
basically.
but basically, it's computers everywhere in the world. So if one facility closes down, the data is still on another facility. I think that there are probably multiple copies of stuff
I would hope so.
everywhere.
Yeah, I would. Yeah, because it is. I mean, it is worrying. I mean, it is so.
Yeah,
It's just
no,
electrons.
but nowadays you have to rely on people still having their disk, or for example, I have some data on microfiche. I mean, from the 70s, there was a
That always
Dutch.
made me sick. I couldn't use it because I'd get motion sickness moving those things around.
Yeah. Well, you need basically, I mean, you need the equipment to read them, because I mean, an A4 is put on a very small spot,
It's kind
but
of brilliant. I gotta say, it's absolutely brilliant, but it's
but
so
yeah,
antiquated now.
yeah, but microfiche don't deteriorate. I mean, you cannot put gigabytes of data on it, but the data from these times, I mean, for example, the one from the Dutch satellite called ANS, Astronomical Netherlands Satellite, or Astronomische Nederlandse Satelliet.
Sounds
So
better when you say it. Yeah.
yeah, yeah. Well, probably because I'm Dutch. But no, the data of one of the instrument, which was built by a company by the Space Research Organization in Utrecht at the time, or in Leiden probably at the time.
Hmm.
They are. I mean, there was one book with microfiche, and the principal investigator, so the one who sort of lead the project or that instrument, he kept a copy.
Hmm.
And I'm now trying to use the data, and probably even a student or even some students may have a look at the data and do some data analysis and see how astrophysical sources behaved at that time and compare them what we know now.
So wait a second. So you're saying that there was the only way you could get it was because someone happened to make a copy and bring it home type thing?
Yes. Yeah.
That is not filling me with confidence with our backup systems.
No.
Like
No, you're right.
that's crazy. So you tracked this guy down or this woman down and got the information, and now
Well,
you've got your students going through this stuff.
this was because I did my so after you get your degree, your PhD, we call you can do some research as a postdoc. So that's post your PhD. That's basically a 3-year position, basically. And one of my postdocs I did at the Space Research Organization Netherlands. I mean, it was on using data from another satellite, but then I met the guy who had that, basically the folder in his shelf. And when he retired, he said, I mean, he knew I was interested in all data, and he said, I give it to you.
Wow. And otherwise, it just would have. Who knows what would happen to it?
I guess it would have been thrown away, or put somewhere in the dungeon or whatever. And
It does make me worry that we need a better like like system for tracking all of
yeah,
this stuff. I mean,
yeah,
because the data disappears, it's gone. There's no.
yeah. For example, just give me a copy of all the movies you were in, and I can archive it how do you say that, for posterity? No, prosperity.
Or
It
just to
will.
embarrass me later.
That's not what I said. Yeah.
There's a few that might be worth missing.
No, but I mean, if you just store it somewhere, it may be gone at
Hmm.
some point.
Well, and I do that. What's funny, actually, I was talking about this the other day, where I do have old TV clips and stuff that I keep
Yeah.
because you just don't know whether they'll still be around in 20 years or whatever.
I mean, for example, we had stuff on. You recorded stuff on VHS.
Yeah, yeah.
As a recorder.
It's terrible. The VHS was terrible. The quality, and also you could only watch it a few times before it deteriorated really
Yeah.
badly as well.
Yeah.
Yeah.
Well, exactly. I mean, we now have discs.
Hmm.
You expose some random laser or whatever X-ray machine. I mean, forget it. So
Yeah,
you
there's. I
need.
remember zip drives were really popular for a while there,
Yeah,
and that's almost impossible to
yeah,
find things like that now.
exactly.
Yeah, it's
Yeah.
neat. It's a neat issue. But okay, so let's go back to you and your work. You're looking at all. You've got like you're kind of like an Uber fan for the Apollo stuff too, right?
Well, yeah, I'm a fan to look at all data. For once, it's just, yeah, I said it. I mean, it's again, you go back to the dreamy astronomy. Things were done very much differently in those times. I mean, you had I mean, people went to remote locations to flew balloons with X-ray with instruments. I mean, not only X-ray instruments, of course. At the times when they did the observation with the ANS, I mean, it was some astronomers got together every day and decided what to observe. I mean, nowadays you have to take care of many astronomers and you plan probably up to a year beforehand. It's not as ad hoc anymore. I mean, So it's a little bit of that part, but also, I mean, you're working with data. I got no competition.
That's
I mean,
nice.
nobody knows how to read microfiche or data from other resources.
Can you scan it? I mean, are you scanning the microfiche in so you can process
Yes,
it, or
yeah.
yeah?
I had a company, so I spent some of my spare money and got a company to scan them, and then they put it into PDF, and then you have to optical character read them, and you get gibberish out, and then you have to make nice numbers out of it. It's a huge amount of work and a lot of handwork to get the
Can
data
AI
out.
help with this at all? AI must be able to do some cleaning up. You still got to
Yes,
check it.
no, I think so, because I mean data are nice in columns, and numbers are numbers, right? But I haven't found a way yet to get AI. I probably need to talk to some AI engineers and geniuses to help me out.
I can put you in touch with a couple, actually.
Yes,
There's a couple I've spoken to.
yes, yes.
Yeah, I mean, just also, I mean, because this is there's similar issues in the biology world as well, where there's old data, but it's also being recorded in a different way and it's used different
Yeah,
formats. I mean, how do you then create a system that you can then integrate that with the new stuff the new observations that you're making? And then, of course, again, getting computers on this stuff is a big part of it as well, isn't it?
yeah. No, I mean, yeah, and you mentioned the Apollo stuff. I mean, how do you get into that? It's just you start doing your research, and then you start to collect the literature, and then you find, hey, somebody did an observation with during the Apollo times, but it was not just the Apollo times. It was done on board of one of the command modules during the Apollo 15 journey. So when they came back, I mean, of course, well, you have to have an instruments on board. So one of the instruments was an X-ray instrument, because they wanted to map the X-rays from the moon to see what the surface composition was like. But when they came back, they looked at various astronomical, I mean, looked at the X-ray sky, and they looked at some famous X-ray sources, because there was a clever astronomer who said beforehand, when you come back, you can look at some sources we are interested in. And years after observation, they made a report, and I got a copy of that report. And then I went into, hey, I want to look at this data again. I mean, not just copy it from the report, but counting the photons. I mean, get your hands on it. And then it happened to be sort of archived on a tape. I got a tape dump, all in binary format, and I can't read that. I mean, as I
Who
said,
can?
I'm not a computer
Yeah,
genius.
you're not a computer. We don't speak binary.
Exactly, exactly. So I got computer students to decode the data,
Oh, they
and
must have loved you for that.
yes, but he could only decode the data because there were some handwritten notes on a printout of the binary format. If there were no handwritten notes on that binary printout, I mean, somebody made a printout and said, this is the format. If that guy or man or woman had not written these notes down, we would never have been able to decode the data.
Wow. And an AI is not going to look at that page and go like, "Oh, look at those notes. That must refer to something else." That's a
No,
human's got to do that.
yes, exactly, yes.
Wow, I picture you sort of like I picture them finding you in the basement looking through things, "Hey, does anyone want this?" Like, I mean, like,
Well, so there was this X-ray instrument on board the Apollo, and the astronauts had to operate them, which was, for them, it was very easy. It was either on, X-ray instrument on, X-ray instrument off, or standby. Standby is sort of, it's a little bit, it's on, but it's not recording anything.
Right.
So easy. I mean, nowadays you have thousands of different modes to record X-rays. But anyway, so if you have that X-ray instrument, you sort of know how does it record these X-rays. I mean, basically, you want to know when an X-ray photon comes in, what happens to that photon. But then you need the description of that X-ray instrument. And as I said, during that time, a lot of the descriptions are on paper. And the institute or the company who made that X-ray instrument moved to Cambridge University, and probably they threw away all the paperwork.
Oh,
because
man.
why would anyone be interested? So basically, we had to, I mean, you either do it.
Oh, he's back. I've got him back. Hello. Oh, I can't hear you now. Is that I heard? Let me see. You may want to log back in. It may still think you're out. I wish my brain had 72K. I will get to questions, by the way. Yes, absolutely. Once we figure this out. There you go. Oh, I got a couch. I've got no Erik. And I can't hear. That's so weird. It like suddenly happened. It's like they don't want us to talk about the mission. He went binary on us. That's right. He's just talking in binary now. Exactly. That's exactly it. Yes, I will get to some questions for sure. In fact, while we're figuring out Erik's sound stuff. Oh, maybe his wait a second. Hello, Erik.
Oh, I'm double.
Yep, I've got rid of you. There you go. Now
Yeah.
you're back. Did your headphones die or something? Or did the internet die? You're very frozen right now, but I can still hear you somewhat.
You can hear me?
Are you at ESA?
Yeah.
Is it ESA? ESA's network is so weird. It's so random on this stuff.
I'm in the show. Everyone can see and hear you. Well, that's not true.
Well, we can see the still image of you. It's a representation of you at this point.
Yeah, everybody can now just save that image and.
That's right. Yeah, and we could just all animate your mouth.
Yeah.
Like just put lips on it. Do you want to try logging back in one more time?
Yeah, I will do that. Yeah.
Yeah. Okay.
So
I'll pop you.
I will leave and come back. Yeah.
Okay. All right. We're trying again. Yes. Questions. I'm going to pull up my email where I have had some people send some questions in. Here we go. How's that?
No, I will.
Still frozen. That's so weird. So it's there's some kind of a limit or something. There's kind of some kind of a limiter on the ESA internet side that because it's usually fine for a while and then it just suddenly that's it.
Oh,
It's
okay.
like, but I can still hear you really well. So if you don't mind continuing with this, maybe we'll just hope for some video later.
Well, I could. Well, let me one more time.
Do you want to just?
Try.
Yep, sure.
Yeah.
All right, there we go. I'm gonna try one more time. Here we go. And questions. Erik questions. Look at this. There's Erik questions. Oh, Sky, thank you so much. Sky sent us some questions. That's great. And I will flick through this as well and see if I can find a way to get some questions asked. So my company. Oh, it's a good company. We've got space companies here too. Ooh. Hello again. Yes, hello. Don't forget to watch CBC right now. It's live. What's on CBC? What's going on CBC that I should know about? All right, Shield's back. If you want to check, here we go. Hello.
Yes, you know what I did?
Ooh.
I
What?
left the ESA the Wi-Fi, and I'm now connected to the my mobile phone.
Great. We need to talk. You know what? I'm going to come over to ESA and I'm going to talk to them about their internet because this is
Talk to my managers. I mean, it's a pain.
It's funny because I know Rob had some actually we've had in some cases it's just better to do these chats from home or even to do them using that you guys use Teams and stuff, and that apparently sometimes
Yeah.
works really well.
Well,
It's just this is such a nice platform for doing it. It's
if I would be home, then I'm now in Spain actually at
Oh, are you?
yes, yes, yes. I'm at the premises near Madrid actually.
Oh, I
Yeah.
love it. You're in Madrid, near Madrid in Spain, and you've got a freaking Simpsons background? Shouldn't you have some exotic Spanish resort in the background or something? I've got some questions for you if you're into
Ah,
that.
yeah, no.
Yeah, I realized that we're of course Agnes on holiday. She's having a
Yeah.
wonderful vacation.
Yes, she's traveling today. Yes.
Yeah. So we're on our own. We got to deal with questions ourselves.
Some people have holidays. Yeah. I mean, we have to
Holidays.
work.
My work. This is the problem with me is my work is a holiday. When I get a job, that's the fun part. It's all the crap in between
I
that's
mean,
the
with
frustrating.
access to job even.
Yeah, yeah, that's it. Yeah, exactly. Okay, wait a sec. Let's get into some questions.
Let's questions.
Okay, so I did a little thing which I call a burn and learn every morning. I try to
Yeah.
do a little exercise and do a little chat. And so today I said, "Hey, I'm about to go and talk to my friend Eric. So who's got questions?" So Sky's come up with a whole bunch of them actually, but
Ooh.
let's pick a few. Are there any upcoming ESA missions you're especially excited about, or that the public should keep an eye on?
Oh, I mean, there are many missions we work on. I mean, for the future. From I mean, and basically at all wavelengths, from optical to X-rays and gamma rays. And I'm involved, as I said, in the mission called XMM Newton, which is already flying for 25 years and doing still great science. But I'm also involved in some future X-ray missions. For example, two missions which will fly in about 12 years, for example.
Mm,
And they look at, well, I mean, and, yeah, and we're also flying missions into the solar system,
mm.
or to look at the Earth environment. So, I mean, it's from close to Earth to far out in outer space.
You've got to have a preference for further out in space, don't you?
Uh, yes, I'm an astronomer. Sorry, yeah. I mean, I have a lot of colleagues who are, for example, exploring the solar system, and we always make fun of each other.
I get the sense I was amazed how many people were at ESA and how they were all in their own little
Oh, yes,
groups.
we are all in our small bubble. Yes, yes, yes. I mean, we do teamwork, but teamwork within a bubble, so it's a team bubble.
Yeah, it's true. It's interesting. I mean, you're all very. It was amazing to me that even that open days were so popular also with the people who worked at ESA because they got to see sections of ESA that they
Yeah.
wouldn't normally get to do. You know,
Yes, exactly.
it's
Yes.
amazing. Yeah.
Yeah. Sometimes these bubbles collapse and you work together. I mean, especially if it's at the. I mean, they do different science stuff, but they may use the same sort of channels of wavelength. Yes.
What is the team that you're in? What would that be called? What's the name for what's the overarching name for what you're doing?
I mean, I'm what is called a project scientist. So I'm taking care of the science of a project, which is XMM Newton, and I'm working with the science operations. So the ones who are planning these observations on a daily basis, weekly basis, yearly basis, and that's basically called the science operations team.
So what's a day for you like? Like what's a is an average
Oh,
day basically at the computer or is it
chaotic. I mean, yeah, sorry, yeah.
No, that's kind of how I saw it. I mean, I
Well,
kind of saw it as like this kind of like organized chaos.
no, you just want to say I come in, read my email, and then I go through the procedures, I do my stuff, but it's chaos. People come in, emails come in. I work on 3 different projects. Sometimes you say, today is my day. I'm not going to work on this project. And then somebody comes in and says, can you do this? Can you do that? And then your day is screwed and forget it. It's chaos. But
Do you work
it's
at home as well? Do you sometimes take the stuff at home so you
uh,
can get stuff done?
since COVID, yes. I mean, I work more at home. I say every time to my family, I'm more efficient at home. But when I get to work, you interact with your colleagues. So, I mean, you're
Which
interacting
is
with,
the fun part too, right?
yeah, not only coffee, of course. I mean, also interacting science-wise, engineering-wise. I mean, you learn from each other.
Yeah.
Also during coffee.
Well, yes. I mean, coffee was definitely a big part of things I saw.
Oh, yes, coffee is essential. I mean, it's not
Yeah.
out coffee.
You're preaching to the choir here. I live
Yeah,
on this stuff.
or tea.
Yeah, tea. Tea in the morning, and then I move to coffee, then I go back to tea again.
Sorry for the British people online, but not tea with milk.
I don't know how you drink tea without milk. That's just weird to me.
Are you
Well,
acting?
to be fair, I also don't know how you do those herring things. Like what are they called?
Yeah, haring. Yeah,
scoused herring or something, or
it's haringhappen.
Hottinghopper. Yeah,
Yeah,
I don't care what you call it. It's still like it's the dipping it in the onions and everything. I mean, I
yeah.
got to give it a go someday, but I
What's
was not brave enough this time.
what's wrong with that?
I picture ESA at lunch and everyone's just like penguins doing this sort of.
Well, I think every Wednesday is fish day, so in principle we could do that.
Oh my god! It's like
Yeah,
feeding the penguins at the zoo. That's how you feed the scientists in ESA.
yeah, but at least we don't throw it to each other.
Yeah, yet. Yeah. Okay, so you've got 3. So you're managing 3 projects. Can I ask what the 3 projects are? Is that
Well, I mean, one is XMM Newton, I said.
Mhm.
So the other one is called Theseus or Theseus. I mean, I don't know how to pronounce it because everybody pronounces it differently.
Right?
But that's a mission which is proposed to fly. I mean, it's still a competition with other 2 missions. Next year there will be a selection, and I'm also working on a mission which is called New Athena.
New Athena. Wow, that sounds
Yeah, it
very
was
sci-fi.
called Athena, but then due to some budget problems and they had to sort of revamp the mission, and now they call it New Athena because it's revamped.
It is amazing how much funding is an issue with these things. I would have thought that people were just throwing money at this stuff.
And the more money is thrown into defense or like that, or I mean, this is just peanuts. I mean, on a how do you say country budget basis. I mean, we
So
still
short-sighted though, because the reality is the things that we can learn are incredibly like I mean, if we want to go to other planets, we kind of have to understand our own and where we are in the scheme of things anyways, right? I
yes.
mean,
I mean, know if there are green little men on other planets or whatever.
be nice to know that too.
Yes, yeah.
I'm convinced they're just avoiding us. I'm convinced that we're like that pig pen in the Snoopy cartoon, that guy who had just that we've got all that stuff just drifting around our head that we
Oh,
just look like. Yeah.
we just live on a pancake and that's it. Yeah.
Oh, now we're going to start the flat Earth. Great, perfect. Thanks
It's a
so
flat-
much, Erik. So wait, okay, so what do these other 2 missions then? What's the New Athena, and would you Sarah's? No,
Yeah. So if you pronounced in English, it would be Theseus with a th. But some people also, I think, from more if you go to the southern European countries, they could say Theseus.
which sounds cooler, to be fair.
I don't know. I mean, these are all Greek
All Greek to me.
mythology people.
Yeah, who is Theseus? Theseus was
Uh,
someone in the chat will tell me. I guarantee you, someone's going to know.
oh, it's horrible. Well, horrible. I mean, if you Google it and look at pictures, I mean, at those times they were really horrific people. I mean, they killed people just with axes or with knives or whatever. I mean, oh no, it's in the Greek times. I wouldn't want to live. I
Yeah, I
wouldn't.
wouldn't make it for long either.
I wouldn't be Theseus or Athena or whatever. Yeah, no,
Yeah, the Greek
definitely.
mythology is brutal, isn't it? It's
Yeah,
amazing how sort of violent that stuff
that-
is.
yeah.
Okay, but what is Theseus or Theseus?
I
What is it
mean,
studying?
some people say, why do you need another X-ray mission? I mean, why do you want to spend millions or even billions and again count X-rays? But all of these missions have a specific science goal. I mean, some of these missions want to be more sensitive, or they just look at a certain wavelength, or want to make nice images. I mean, with better resolution, or oh, terrible. I'm back, but I don't hear you. I don't hear you. So you hear me? Uh, okay, let me check if it's my headphone. Oh, this is. Well, you can just keep talking, and I don't hear anything. So.
Oh, now David's muted. There you go. Yes, of course. No, sorry. I've been muting myself to stop myself from interfering with your audio. Can you hear?
Oh, so you're muted yourself.
It was my fault.
You wanted to say something to the audience.
No, I did. No, what I've been doing is I've been muting myself so it doesn't interfere with your. Because for some reason, when I was on, it was taking away some of your audio. So that's entirely my fault.
Okay, good.
Yeah, just to be
Yes.
clear. Yes, you couldn't hear me because I've got a little mute button here that I like to hit when Erik is talking, so it doesn't interfere with his audio. And I forgot.
Yes, and I don't have that button where I can mute you.
Yeah, yeah, that's the superpower. You need one of these little microphones right here that has a little button on the top. Yeah. Okay, so Theseus is going to be a more sensitive X-ray detector.
Well, it's going to. Well, I mean that mission is specially to look for certain objects. I mean, it does not only have an X-ray instrument on board, and actually a gamma ray detector, but also an infrared detector. So it can. So when it finds something in the X-rays or gamma rays, it can use the infrared camera basically, which has a better resolution and better sensitivity to see what are the X-ray instruments and gamma ray instruments actually detecting. And they are designed such that they can look for certain objects which we call gamma ray bursts, which are probably the most violent objects in the universe. I mean,
Yeah.
these objects emit, I mean, maybe I mean, loads of X-rays and gamma rays within a couple of seconds. Probably the output of the sun, what the sun does in a year, just in 1 second. So
Wow.
if this would
How often does
happen,
this happen?
I mean, they happen. I mean, we see them. Well, we detect them every day, and sometimes a couple of per day, and they come from everywhere. I mean, every direction. But luckily, they are far, far away from us. I mean, if that would happen in our galaxy, we would be fried. I mean, forget it.
Wow.
I mean, the Earth atmosphere, it would be heated up, and yeah, then we're gone.
And what causes these things? Is that what we're trying to figure out?
Either a collision of, I mean, again, we are talking about binary stars, for example, maybe two neutron stars which are the heaviest objects we can still see. I mean,
For
if
black holes. Black
yes,
holes
I
being
mean
the heaviest. Yeah.
compact. So these are the most compact objects in the universe. I mean, for example, Amsterdam would fit in 10 kilometers of a neutron star.
Wow.
So, so yes,
So they're that small?
yeah, they're very very small. So the sun would fit. I mean, just imagine that you would compress the sun into the size of Amsterdam, so 10 kilometers basically, and it's that compact. So it's only when neutrons survive basically, and
Wow.
that's why neutron star. And if you would compress it even further, then you probably go into a black hole. But but basically, so these gamma ray bursts, they can either happen if there are two neutron stars orbiting close to each other and they sort of coalesce, so they become one, and then you get a huge burst of X-rays and gamma rays.
Wow.
And
And then you go, "Oh, great. Spin that infrared onto that. Let's get some images of
yes,
what's going on."
and of course, I mean they don't. I mean most of the radiation is emitted within these seconds, but then they also have a kind of what we call an afterglow. So it's like a candle. I mean, you lit it, and when you blow it out, you still see a little bit of light at the top, and then it fades away. It's the same kind of, and this fading away is better seen in the optical and infrared. That's why we have this infrared camera on board. So as soon as you see this burst in X-rays and gamma rays with a wide field of view camera, X-ray camera, you immediately point that satellite to the position with and have a look with your infrared telescope.
Is there any way to predict them? Like that they're going to happen so you can actually get an image of no,
No,
really completely random. Wow.
yes, completely. That's why you need this X-ray gamma ray instrument first with a wide field of view. I mean, really wide, so that you can get them from anywhere. And then with a dedicated telescope, go as soon as you detect them.
Are we eventually going to have a wide enough field of view that we can basically take it all in, or is that impossible?
No, because the either the Earth is in the way, or the planets are in the way, or the sun is in the way, so we cannot see the whole sky. I mean, if you would point that
Of course.
telescope to the sun, it would burn the whole thing because the sun is so bright. Forget it. Yeah, you
And
fry
that
the.
is just going to blow out anything that you might be able
Oh,
to see.
I mean, it's so sensitive. I mean, the instruments are so sensitive in detecting photons that if you throw too many photons on the instrument, it will yeah, it will collapse basically.
Wow. And we've got stuff pretty close to the sun now too, right? Don't we? We've got like things.
Not instruments close to the sun, but they are built to survive the sun. I mean, it's also quite hot.
Mm.
Sun.
So I've
In the,
heard. Yeah.
when you're walking in the sun, it's hotter
Oh
than
yeah, man. I hate walking on the sun.
so. But also they devise the instruments such that they can look at radiation from the sun.
So they're like tanks with a little tiny sensor on them, basically.
Yeah, I mean, you have to protect. Yeah, really protect it.
It is
Yeah.
amazing that we can create anything that can withstand that kind. Like the fact that
Oh yeah.
I mean, space always looks so sort of like dreamy and
Oh, no,
floaty, but
no,
it's just
no,
brutal.
go into space. I mean, there is lots of horrible radiation, UV, X-ray. I mean, sometimes there are these outbursts from the sun, and they throw a lot of. I mean, the sun throws a lot of stuff: electrons, protons, X-rays. I mean, don't get exposed to that. I mean, the astronauts, when they are in space, they get a lot of these rays and what they call the plasma. It goes through their body, and and may even destroy part of their body cells.
It's crazy. We're just not designed for. We're bags of chemicals. I feel like we're not designed for space. That's why
No,
I prefer the robots, because I feel like we could get further and get a better view of things.
no, forget. We are biological systems, and it gets destroyed when you put them out in space.
Yeah, yeah.
Yes, I mean when you do the acting, I mean
Hmm.
that's nothing.
It's
I mean
true.
when you go into outer space, it's nothing.
Yeah, yeah,
I mean you just walk around on a planet and nothing happens.
yeah.
But if you put an astronaut, our astronauts onto Mars,
Mars
without
seems like madness to me. Mars seems like the craziest
yeah,
possible like place to go, like because it's everything wants to kill you.
I mean suit, forget it. Even on the moon, you need something to protect you. And even I think the suits they had, I mean, uh, they got radiation damage for sure.
So you're not advising people go to space.
No, let's keep us here.
Yeah, that's so funny. There's a wonderful I was sort of very much just pro the robotics. I was thinking like, let's get the robots out there looking at stuff, because I feel like then we're spending less resources on trying to maintain
Oh
this
yes.
fragile existence that is us.
Oh, and it's so much cheaper to put robots in space instead of humans. But on the other hand, humans are more intuitive. I mean,
For now.
they, yes, there are some books you don't want to read, and in 10 years, it's all AI and robots.
Yeah, yeah, yeah. I know it's the answer to everything right now, isn't it?
Yeah. No, but I mean, yeah, no, it costs loads of money to put humans into space. I mean, it's still um, it's an adventure, and maybe at some point we should explore more. But on the other side, there is loads of money going into it, and which we can also spend either on Earth or in other research. I mean, people are dying on Earth, but we put only a few men and
It,
women in space, and for loads of money. Yeah.
to me, it's like marketing to some extent, where I feel like it's first off, there's like an instinctive desire to I think explore. Like, I mean, I think there's that to go to places. I totally
To
understand
go
that.
boldly beyond. What is the quote?
Yeah, to
Yeah.
boldly go where no man has gone or no one has gone before. Were you a Star Trek? You were a Star Trek fan, right?
Yes. Well, more or less. Yes. I like it. Yes.
But
I
that wasn't you. Star Trek isn't the reason why you're doing this.
No. I mean, fan. I mean, I've gone to a Star Trek convention. Yes,
That's
but
pretty. That's pretty much Fanny, isn't it? That's like, you know.
but it was also part of. We had an ESA booth actually. So
Okay,
uh,
fair enough. Fair enough. You had an excuse.
I mean, the same thing for the Comic Con. It was a kind of science fiction, science connecting with fiction or science fiction, and people were very interested in the also the real science fiction.
That's what I love about it.
Yeah,
The original idea of science fiction was it was science. It was speculative, basically. It was like the idea of like, how do we
yeah.
take the science and project where it could go in the future? It's become a lot more fantasy as well now, I think. Was there were there do you are you a, do you read any sci-fi, or do you any or you basically you prefer the real stuff?
I mean, I prefer the movies, I would say.
Really? So you don't not
I've
reading the books, you're watching the movies.
well, I've read a couple of books, but then I mean, to be honest, there was a book about life on a neutron star, so it's sort of closely related to your research. I mean, these was about, of course, the people or the creatures living on a neutron star. They are flat because they are crushed. I mean, the gravity is so large that I mean,
Wow,
uh,
they got to be the pancakes, basically.
yeah, and mountains are maybe a few centimeters high at most. And then so people on Earth knew there was a neutron star coming sort of close by, and then they wanted to get to interact with each other. But time flies by. I mean, when gravity, again, theory, when you're close to a neutron star or close to a black hole, time goes faster than at home, I mean, on Earth. So they had to sort of try to interact with the time scale.
This just reminds me of a book called Flat World, which was about two-dimensional beings trying to.
Yeah, I forgot the name of the book.
I wonder if someone in the chat knows what it is. That'd be great. Yes, we can see the chat, by the way. I'm just honestly, with these chats, what I like to do is focus on our fabulous guests. And then normally Agne would be in here doing questions for us. But I do have
Okay.
a few more questions for you. I'm completely I'm monopolizing you, I know. Okay. Are there moments where you feel the line between physics and philosophy blurring?
Well, basically, I mean, what we're doing is part of philosophy.
Mm.
When you try to interpret what you see, you're sort of philosophizing. Is that the English word? What is happening miles and miles away?
Mm.
So, I would say yes. Yeah.
So you still have to. You're basically still trying to. You're still trying to put things together so that it makes sense, which I guess in
Yes.
a way is still a.
I mean, it's visualizing something which you cannot see.
Mm, mm.
Yeah.
God, that's amazing. I think it's so funny that when you decide to read a book, you read a book about flat beings on a neutron star. You've got a focus here.
Yes, I must say that. So I mean, I read a couple of, I mean, really sci-fi. Let's say, for example, the one which are in the movies. I would not read as a book.
Mm.
I prefer to see the actor. Well, some actors.
You say all the right things, Erik. You
Yeah.
really do.
No, but what?
Like The Martian, like for The Martian being one that comes up all the time, obviously, because it was the one that was sort of claiming to be as close to reality as it could get with some, you know.
Gravity. I mean, Gravity, the movie. That's. I think in for that movie, also some scientists were involved, and even some physicists. I think. I mean, sometimes sci-fi movies get it wrong.
Oh yeah, all the time. I made it myself.
Yeah, yeah. I mean, sometimes you see these huge galaxies interacting with each other, but I mean, if you do the actual simulations, how that would work, I mean, you got it wrong, really.
I wonder if it'll get more accurate now that we're, I feel like this stuff is more out there for people, like it's more available to people. So maybe
Ah,
maybe the expectation of more realistic science fiction is.
also, I mean, making animations is now more easy. I mean, not the
And they're
AI.
beautiful too. The animations are extraordinary.
Yeah.
I don't know if they're accurate, but they sure look good.
No, but then you can feed in what we do. You can feed it in sort of into the movies, so it'll be a little bit more accurate. I mean, I'm not talking about AI because that even AI may get it wrong. But
Yeah, well, an AI is only using the models we already have or the
exactly.
animations we already have, so it's just going to get the
Again,
same things wrong.
what you put in is what you get out.
Garbage in, garbage out.
Yes.
The old programming thing, isn't it?
Yes. Actor in, actor out. Yes.
Yeah, okay, so let's see some other questions.
Yeah.
Are there any questions in the chat specifically? Has anyone got any questions that have come up?
Uh,
Let's have a look here.
yeah, there are so many messages that I
Yeah,
don't.
it's hard. Well, this is why I don't focus on it, because in a chat like this, I think it's just important. We could just get lost in this stuff. So, um, let me go back to there's some Sky's questions were great too. Let's see, Erik. Here we go. What does Erik think about the science community revelation that removes the negative energy requirement for faster than light travel? Wow, there's a doozy for you.
Well, again, that's theory, and I wouldn't know. That's all speculation.
Mm-hmm.
I
Faster
mean,
than light. We're obsessed with faster than light, aren't we?
most of the theorists say you cannot go faster than light.
Mm-hmm.
I go with the flow in that sense. So, no positive energy, And to be honest, I mean, it's better to be positive than to be negative.
Yeah, well, it's an easier sell if there's a chance it could work, you know. And again, but that also just comes down to us wanting to. This goes back to the astronaut thing. It's us wanting to be somewhere else, to go somewhere other than where we are.
Yeah, yeah. It's seeing new things. I mean, explore the unexpected. I mean, you will getting bored doing the same act every day, right?
Oh yeah, that's why I'm an actor. Doing the same thing every day is like is
I
misery
mean,
for me.
exactly. So you want to do new things or go a little bit next to the path you're walking. I mean, if you see somewhere something nice in the far distance, you want to see what it is. I mean, feel it or touch it or whatever.
Is there,
Mm.
if you could have like funding aside, let's say they said, Eric, you've just won the lottery. What do you want to send up, or what will be your next mission for you? If it was just up to you, was there and money was no object? Is
Well,
there anything in particular you do?
well, I first would buy a nice car for myself. No,
Damn, I shouldn't have mentioned the lottery.
yes, you should not have mentioned.
What kind of car? What's
I
your
would,
what car do you like right now?
uh, oh, as long as it drives and I can connect it with CarPlay or whatever.
You got you are a real automobile aficionado, Eric.
I mean, uh, not cold and I don't get wet into the in the
Right.
car itself.
Right,
And
exactly. But what sort of stuff would you like to
no,
do maybe?
try to fund the missions I'm working on. I mean, it's already difficult. Sorry, it's already difficult to fund these missions and make them as sensitive as possible. Sorry. Oh, I don't hear you anymore. Did you
Oh,
touch
that was
the?
me. It's me. That's me. Sorry. Yeah, yeah. Um, so okay. So well, that's neat though. So you like the missions you've got. You just like to have some more money and time for them, basically.
Yes, or probably fund a mission
Hmm.
which promotes your own research.
Right. What is your own research? So what would your own research be?
Well, then we basically come back to the start of the conversation. I mean, I'm mostly looking. I'm mostly looking at old data. Uh, if you're working on new missions, I mean, people would not probably like it because, I mean, most of the funding goes into new stuff, new instruments, new missions. And if you're saying looking at old data, then they say, well, why do you want a new mission? Because there is old data available. So
Oh, that's interesting. And also, it's not as sexy, is it, to say like, oh, I'm going to go back and look at some old data.
but we can still, I mean, science-wise, we can still learn a lot. But if you're talking to industry and funding and getting, I mean, most of the time, industry wants the funds when you um, develop new things, new instruments, more sensitive instruments. That's what they like.
Right. Yeah. And it is. It's always the sexy. The new stuff is always the
Yes.
latest technology. Is
Yeah.
always the. That's interesting though. I wonder if are there funds from a historical perspective that you can access? Is that
I mean, sometimes they have these. I mean, but these are small funds. For example, at NASA, they have calls for doing archival research. Yes, and I guess in sciences they have that, and even here at ESA we have some small, very small funds to look at the archival data from ESA missions. Yes, but I mean, then you're talking about peanuts. It's not big.
is this something that could be crowdsourced? Like, could you get sort of amateur astronomers or to be wading through some of this data for you?
Yeah, I mean, some of it is outsourced. Yes, I mean, you have these what they call these projects. For example, looking at images from the Hubble Space Telescope and try to identify galaxies. I mean, their form, and so you throw every time an image of a galaxy to the people who want to classify what kind of shape they have. And you can do the same, for example, with a project like, the data from the ANS, which instead of letting AI trying to reproduce the numbers, throw the PDFs, so the scanned pages to the public and let them do the analysis and convert given numbers.
Well, and basically, I guess the same thing with the James Webb Space Telescope as well, where he's got these huge images
Yeah.
that I guess you could just pick a section to zoom in on, and it'd just be nice to know who's looking at what, so you're not replicating someone else's work.
Yes, there is so much information. There aren't enough astronomers to analyze all the data. So what you can do is give it to the public, and you will always find something, and maybe something new.
And there are science fans and space science fans out there that I'm sure would want to help with this. That's fascinating. That's neat.
Very objects or very nice objects.
How are you holding up, Erik? You got time for a couple more questions?
Yeah, no, I'm fine.
Okay, this is a Nixie. Oh,
you already warned me it could last hours, so
it's not. It's as long as I don't want to exhaust you. I just normally an hour and a half. We usually go to the questions, and then we're at we've got.
So can I go?
Can you go now? You want to go now?
Yeah.
Yeah, that's fine. We can wrap it up now if you want to.
No.
Yeah.
No. Wait, I'm still okay. Apart from the coughing, but
we'll suck the last little bit of life out of you before
Yeah.
Okay, so Nixie Geek has a question.
I will become a black hole in the end. Yeah.
That's it. Perfect. And I will be a neutron star.
Shining.
Okay, Nixie Geek has a question. Gravitational waves moving with the speed of light. Is it possible that two different forces or energies moving with the same speed, or is one limited by the other's force? So I think the speed of light is limited because of the speed of gravitational waves. Sounds.
It's basically no, but we have already proven a couple of years speed of gravitational waves is more or less the same as the speed of light, and I think this comes down to the fact that information cannot go faster than light.
So that would limit it then.
Yeah.
How do you measure? How do you figure that out? How do you figure out that they're moving at the same speed?
Well, we now have we have some gravitational wave observatories on Earth. Basically, you have a long baseline tunnel, and as the gravitational passes by, it changes a little bit its length. A little bit. You're talking about
tiny
micrometers of length, but these tunnels are so sensitive nowadays that you can measure that.
I wonder if they're using the quantum. Are they using the entangled quantums and all that kind of?
It's really measuring the length of. So what you're doing, you're firing laser bundles from one part of the tunnel to the other one, and you're doing that constantly, and you at the other end you reflect them back, and then you can basically measure the delay when a gravitational wave passes by, because it changes the length of the tunnel. And once you know where it comes from, that's why you need the electromagnetic radiation, the optical or X-ray, whatever, and then you can start. So if you see the signal at the same time, both the gravitational wave and the electromagnetic radiation, so the ones in the optical or X-rays or whatever, then you can say they come from the same object. You see them at the same time. So the speed of both of them,
It's traveling the same speed. Wow.
and that's sort of discovered in 2017 for the first time.
Wow. Really?
But you were talking. I mean, there is again a theory which says if you go on a quantum level, if you change the state of an atom somewhere far out in the universe, it will automatically change.
Mm.
It will flip sort of
The spooky
the
action from a distance?
somewhere way at the other end of the
Yeah.
universe. Have not, as far as I'm aware, we have not proved that
It
yet.
is definitely
But
the stuff of dreams, though, isn't
maybe,
it? It's the with the like the entangled photons, and we
yeah.
don't know where it breaks or if it breaks.
No, that's really happening. I mean, then we can send information faster than the speed of light, and then we can connect to outer
Yeah.
worlds if there are.
God, that would be amazing. Wow. Okay. See, this is the stuff,
Yeah.
Okay. So another question from Sky. What do you guys think about building a giant telescope on the moon? Is that helpful to us?
Oh, yes. I mean, there are people, for example, they want to. I mean, if you put them on the dark side of the moon, for example, you don't have the interference from the sun,
Mm.
Earth, and people are thinking putting radio telescopes on the moon, because I mean, if you put them on, well, there are radio telescopes on Earth, but there is a lot of interference from radio
Earth.
signals.
Yeah.
I mean,
It's
phones.
all those Stargate shows.
Yeah, I mean, even this chat. I mean, it's interfering with a lot of stuff. But if you put them on the, for example, on the far side or the dark side of the moon, there is no interference, so you get more sensitive.
Would
Yes.
they be more or less susceptible to damage on the moon than they would if they were in like orbit around the moon or
Uh, I mean, you're more susceptible to the high energy radiation. I mean, X-ray radiation, electrons, or whatever. But most of it would be captured by the lit side of the moon.
huh?
So the far side would be less prone to that.
Mm.
Yes.
That's neat. I mean, I imagine that's one of the hopes is that we'll get to a point where we can have some more observation stuff on the
Yeah.
moon.
People proposing projects. I mean, it's not that science fiction anymore.
Yeah, the moon thing. I got to say though, I still feel like we're behind on the moon. I feel like we should have some more stuff going on up there.
The difficulty is who claims the moon, and there are a lot of political questions to be resolved first.
Space law.
I mean,
I talked to Netta last
yes,
week. All
exactly. Space law it's in its infancy, and there are a lot of hurdles to be tackled. I
it's
mean,
science
we
fiction.
thought,
Space law is basically trying to
oh yeah,
figure out what could happen in the future.
I mean, we thought we solved the problem with the ISS, but if you go beyond the ISS, it's unexplored territory. I mean, you cannot just put a flag onto a on a out of space body and claim it. I mean, that's not how we
It's
work. I mean,
amazing.
some
It
people,
is how we work. That's the problem in a way, though, isn't it?
yeah, how, yeah. At the moment, this is how it works, but it's not how we should work.
Nixie Geeks made an interesting point here. So they do citizen science, as they call it, through
Yes,
zooniverse.com.
yeah,
You heard of this?
that's yeah, these are these projects for the public, and you feed them with images or information, astronomical information, and you can say this is a round galaxy, this is elliptical shape, or whatever. And if you're working with images, for example, no, but this is exactly.
So that's legit. That's a
It's.
good. That's a place for people to go for this.
I mean, if you're interested in astronomy, but you're not doing at a professional level, I mean, this is part of you help a lot the professional astronomers. Yes.
That's great. Yeah, no, that's amazing. I love this. That's exactly the kind of thing I was looking for. That's fine. Thank you, Nixie. That's
Yeah.
perfect.
No, that's where the amateur, basically the public and the amateur and the professional astronomers meet each other. Yeah.
Here's an interesting question, which I hadn't thought of. So, what language do they speak at ESA? I mean, is there a universal
Yeah,
language?
I
Is it
just
English?
finished the question as well. Yeah, I mean, well, the official language is English and French. I mean, these are sort of in the how do you say that, in the rules of the agency. But but in practice, it's mostly English.
Really, English is the go-to.
It's French, but talking about my project or science in French is a little bit more difficult. Yes, I mean, I can say je veux une baguette. Yes, but
Très bien, Eric. Beaucoup de
yeah,
français.
mais, mais parler français, c'est horrible.
Yeah, moi,
Non.
moi aussi. J'ai étudié le français pour toute l'école, mais j'oubliais tout le français.
Oui.
All right, I'm going to look for some more questions here. Let me just double check my email because people are.
No, but the people come from a lot of European countries, so you hear Spanish, Dutch, English, Italian, Norwegian, Swedish.
Here's an interesting one. What drew you to study high energy astrophysics? Was there a moment where you went, OMG, like, this is it?
Well, to be honest, very boring. I mean, it's what I said. You do your PhD on a certain subject, and there need to be an opening. And I went from doing optical astronomy in doing X-ray astronomy. I mean, it is exciting because you're looking at extreme objects. I mean, exploding objects, black holes,
Yeah, that must have been appealing on some level.
and but I didn't know that beforehand. No,
Do you,
that was not through my attention to this research. No, it's just what is available. I mean, you're studying at a certain university. They do some kind of research, and you just flow.
yeah,
Yeah,
you
yeah,
go
flow
where the
into
work
it.
is. I guess I mean, it's like, oh my
Yes,
God, I'm lucky to be
yeah,
doing this. What's available?
it's like acting. I
A
mean,
big part. Yeah, yeah, absolutely. That's it. Well, it's funny. My wife has interesting. She got into television because there were two jobs available when she started, two volunteer positions. One of them was on a film. The other one was on a TV thing. The TV thing was 4 days. The film was two. So she went to the TV because
yeah,
and and has now sort of returned to film because she's chosen that. But
yeah. I mean, of course. I mean, the sort of the subject. So I was interested in astronomy.
mhm,
Fine, yeah, but then there are many ways to do astronomy.
yeah. Yeah. Do you do it at home? I
You,
mean, do you have like a telescope at home and stuff? Do you do any of that kind of
no,
really?
no, I'm just
So how do you
a
chill? How
laptop
do you chill when you go home? What are you doing?
chill. I mean, I drink beer and go out with
Oh,
friends. No,
how unique for scientists. That
uh,
was I got to say that was great beer and food. I might say.
but no, but to be honest, I mean, when you're on holidays and you are in a place where there is not much light
Mhm,
pollution, then, I mean, you admire the night
mhm.
sky. Yes,
Right, but no more than
but
no more than a nerd like I would.
no, I mean that's chilling out. But I would not do that the whole
Mm.
night. Uh, and be deprived of sleep the next day. I mean, and the second thing is that I'm too old for
You're
these
like
kind
the
of things.
grumpy
I mean,
old man of science.
yeah,
Get off my
yeah,
lawn.
I that's exactly. I mean, we do this funny. Oh, I mean, Oliver. I mean, a colleague of mine.
Yeah.
I mean, I name names in this chat, but I mean,
Oliver is
we are
very
two.
similar. It's very very
Yeah,
practical, down
we
to
are
earth.
two. I mean, the Muppet Show.
Waldorf. You
That
go.
is.
Oh my God! You're the Waldorf and Statler
Yeah,
of ESA.
exactly. Yes, exactly.
That's so perfect. You're literally like one holding up the. People have questions, and you're like, "That's stupid." Yeah,
Yeah.
that's great. Um,
But we
well, here's
but we have we no, but we are still enthusiastic in what we do. but it's just a little bit more, how do you say that, down to earth. I mean, I'm not, if something is happening, I'm not running out of the door I mean, where there is a comet and I know it's out there, it's at 10, 11 in the evening, it's dark, then I say to my wife and children, there is a comet outside and you can see it. But if it would be at 3 o'clock at night, 4 o'clock at night, do you want to get out of bed? Maybe
I'm
not.
such a nerd.
I mean,
I
no,
do that sometimes, but and much to the chagrin of my family, who's like, I'm like,
yeah,
Baz, come look at this. He's like, oh God, just let me
yeah.
sleep. Uh,
Oh, it's like being in a movie. Uh, do your kids like to see you in a movie?
nope. Nope. And visiting set is like the boringest thing in the world. That's the funny thing. I think we all find what we do somewhat boring because we do it all the time, right? I mean, film sets,
Yeah,
I still, there's a certain magical quality to the film set, as I'm sure there's a
yeah,
certain magical
yeah.
quality to
No,
going to
no,
ESA every day.
that's not a problem. But it's just it's an everyday thing. I mean, I'm not doing when I go home. I don't. Take a astronomy book or astronomy magazine and then read all the things which are going on. I mean,
Yeah, yeah, I guess you need to well, that's look, I will also say this. I think that the Europeans are much better at this than the North Americans are. We tend to be like 150% focused on and no time for
oh,
family, no time for relaxation. What I loved about Europe was this wonderful sort of mix where you could go and have a discussion with a bunch of scientists and it could be about anything. It doesn't have to be about their science or their, it's
well, I mean, well, there are also Europeans. I guess the early, well, maybe 100 or more than 100 years ago, those people moved to America,
yeah,
right?
that's true. It's that sort of puritanical work ethic thing, you know. Here's a sort of a related question, which is kind of good from world production. Is there a maximum age to go into astronomy professionally? Like,
No.
no.
Oh, professionally. I mean, of course, the older you get, I mean, the earlier you go into retirement. So,
Well, world
I
production is
mean,
saying, or is 25 all right? I don't even remember
um,
25.
oh, 25, 25. I mean, that's quite young. I
I would
mean,
call it that.
you first have to finish high school, then you have to do your PhD, then you have to get experience. So you do your postdoctoral work. I started, I mean, really professionally, I guess, somewhere in 2015, something like that. No, sorry, 2000.
You've been doing it more than 10
Yeah,
years, haven't you?
yeah, no, that's true. So
Yeah.
2005.
Yeah.
Sorry. Yeah.
We do that as we, 2000 sounds
So
new to me.
so that's 34. Yeah, yeah, yeah. So around your 30th
Yeah. Well, so
birthday.
so
Yes. Yeah.
25 is certainly not too late.
No,
And again,
no.
it also depends on what kind of aspect of it you want to get into, right? I mean, there's so many
Yeah,
different angles.
you have young blood into the system, but they are more agile, and I mean, we are grumpy old people. I mean, not. I don't want to say grumpy old men because there are also grumpy old women around, of course.
It's true.
Um, no, but we tend to use the stuff which we learned decades ago, and the new people, they are more. I mean, they have their hands on new programming language,
Mhm.
new tech. Uh,
What is it?
so
What is it? What's generally used? Is it Python or what are people are programming in these days?
at well, I would say in astronomy it's mostly Python, but there are also new languages
Mhm.
available. I mean, if you're nerd and into fast, I mean, probably Python is not fast enough anymore. There are other languages which are better.
I gotta say, I love Python. Absolutely love it. I think it's amazing what you can do with it.
I, I mean, I'm from the old generation. I still use Fortran.
No.
Yes, and it works. I mean, for my work,
Oh my God, you're the
and
first person I've ever spoken to.
And even I managed to run Fortran on an iPad.
Really? What, like an emulator of some sort, or is it online thing?
Yeah, yeah.
Oh my God,
There are some
Fortran! That's so cool.
where you have a Linux environment on an iPad, and you can do everything. I mean, I can do all my work on an iPad,
I
and
think that's where we're going. Like, I get the sense. Like, I love my iPad. The thing about that I right now is that my laptop has a better battery life than the old iPad that I have. But as soon as I
uh,
can, I'm going to a high-powered M4 iPad because, frankly, I think that's where it's all going.
yeah. But if you want to do heavy computing, then still laptops are the way to do it. I mean, imagery processing, all these kind of things, the theoretical work. But what the things I do on a daily basis, I would say, can be done on yeah, on an iPad,
It is
basically.
it
I
is
mean,
amazing the access we've got to stuff now, and also the
I mean,
online computing stuff you can get to.
yeah, yeah, for sure, yeah, yeah. No, but then you need access. Oh, somebody crashed into your office.
No, not yet.
And
I can hear
oh,
this movement around the office. So yeah.
oh,
Oh, and Pascal as well. Yeah, yeah. There you go.
please stop the podcast because it's getting boring.
Nope, not at all. I'm not bored at all. Neither is anyone else because I'm seeing lots of stuff going here. Pascal was another one that people were talking about. Um, and oh, there was a question about the not really your thing, but is there no higher risk of watching the northern lights than any other time? Like the lights that are solar wind interacting with the polar atmosphere and the Earth's magnetic field. That's it being stopped rather than it getting through, is it not?
Well, it gets through at the pole. Well, I mean, it gets through to lower levels in the atmosphere at the poles because because of the magnetic
Mm,
field of the
mm.
Earth. Um, I think it would on the pole, you get more prone to radiation than if you're living in Europe or near the equator.
Really?
Yes, 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 yes. Yeah.
Never even
I
considered
mean,
that.
it's
Not a
just because
dangerous amount.
no, not. I mean, there are uh, penguins living there or Eskimos, and they still are there. So
Yeah,
I mean, it's
they
not
don't have
that
two
you.
heads and sort of, yeah.
No, no, not something which you would have near a nuclear reactor or something like that. I mean, but still, no. I mean, it's just because the radiation gets closer to Earth, to the yeah, right. That you see that.
Okay, another great question for you. Let's make this the last one. We'll wrap it up because I don't want to exhaust you because I want to have you back at some point.
No, that, if you're exhausted, then
I don't do exhaustion.
oh,
Yeah.
really?
My 10-year-old daughter, this is from Genjing09, says, my 10-year-old daughter wants to study physics or engineering. She loves string theory and quantum mechanics. Wow, good start. Any advice on content or study paths that are targeted towards younger students? Physics and engineering, string theory, and quantum mechanics. That sounds more like the philosophical side.
No, well, I mean, if you want to do that, then it's you're getting into physics and mathematics, and so you need to get a degree, and yeah, you have to go to university to do that. But if you want to do that, just put it into your head, and then you go.
How did you
I
find
mean,
the
be able
studying? How did you find all of the schooling side of this stuff? Was it
to.
tough work?
Well, I think at high school we got information that you could do physics or astronomy. I think at some point at high school you should get information about the path you can do after high school. Um, I mean, I had the problem, for example, getting information. So, what if you have done your PhD and your postdoc? Is there life? I mean, do you is there only life at the university, for example? And the answer is no. I mean, you can if you have done your studies and you have got your PhD, you can also go into industry. You can go into engineering. I mean, I went into the ESA environment.
Straight out of university?
No, well, I first did my postdoc. I went to Oxford, for example,
Oh,
the
right, of course,
university,
right, yeah.
so research, and then I went to Utrecht in Holland at the Space Research Organization in Utrecht. That was more. I was still doing research, but involved also into X-ray missions. But sometimes, yeah, I think it's basically the information flow about what can you do after you've done your high school. What can you do after you have done your PhD? I mean, there are so many possibilities. There are hundreds of jobs outside. It's not only if you have your PhD, you go maybe at some point you become a professor or you go into the academic world. I mean, if you want to do that and that's your goal, then go for it. But there are so many possibilities. I mean,
And you don't have to, I mean,
it's
one of the reasons why I love, I mean, not having gone to university, but what I see with my son now is that it's that's where you find out what you wanna do. Like, that's
yeah.
where you can whittle it
I
down to
mean,
what you want.
if you're happy with a job, then it's fine. I mean, I'm happy. I'm so happy talking to astronauts sometimes, looking at old data. I mean, I even went to the archives in Fort Worth, near Chicago. I mean, these are
Wow.
the cherries on the cake. And when I did optical astronomy, I mean, going to an observatory. I mean, if you enjoy your job, then it's fun enough.
It just doesn't feel like working.
Like garbage, and you love going through the streets and meeting people. And if you have that vision, I want to go into quantum physics. I mean, please do.
Yeah, talk to Lisa
And
Werner.
and the internet these days is your friend. I mean,
It was
there
something,
are
yeah, it
probably
was something that I saw a lot when I
yeah
talked to, science fair students. They almost
yeah
invariably discovered what they wanted to get into for the science fair on YouTube, and then just contacted the people who were making the videos, and
yeah.
that's how they got their info.
For example, today there was a stand of all kinds of companies in Holland and showing what they're doing. I mean, the breadth of things going on, it's amazing, even in a small country as the Netherlands. And I guess it's the same in Canada and in every country.
It's one of the reasons why I love doing these as well, is because I think it's just so important for people to know that these jobs exist, because
Yeah,
they're not necessarily the things that leap out at you, you know, when you're at high school or whatever.
and you don't on a computer to do your research. I mean, there are also how do you say this? Experiment setting up in a lab. I mean, there are so many cool things to do.
Where are you based? Where are you based at Jinjiang? What are you looking at? What is she looking at in the way of schools? Uh,
Uh,
so so wait a sec. Okay, I like this. Hang on. Just do this. I went to Oxford once. This is Sat Tracer said, I went to Oxford once, fell down the stairs. I was there to hear a lecture on physics.
oh yes, there is a very ugly building in Oxford, and that's where I was
Oh,
based in.
really?
And I there were stairs there that yes, you can fall from them. But Oxford is a nice city. I mean,
Oxford's beautiful. Yeah, absolutely beautiful.
yeah.
Got it. Well, apparently they got a big laugh from the class as the professor used my fall to demonstrate physical laws of gravity. That's great. Like a true scientist. She goes to a
Oh,
private Christian school, but is way ahead of their teachings. Wow. Okay. And where's that? Where is that? I'll be curious to know. Is that in the States or in Europe? Perfect science. Look at that. Well, look, I don't have any more questions coming in. So unless anyone wants in the chat wants to jump in, I feel like we'll be back at this, Eric. I feel like we're gonna have to have another one of these chats because
uh,
there's I'm sure stuff will come up from this that that we can go on further.
Oh,
Is there anything in particular that you're excited about in the future? Like, are you looking at any science news and going like, "Wow, that is gonna be that's gonna be a game changer."
again, you should have sent this question beforehand, because then I can pretend to be very
No,
enthusiastic.
no, no, it's supposed to be about just the things that, is there anything I'm just, it's just like if you're flicking through the news, is there stuff that you see that you go like, "Wow, I'm."
Well, no, again, it's getting everything out of the old data. I mean, we're, for example, looking at one event which was seen by the
Mhm.
astronauts. I mean, it was a burst of radiation. For years, I'm, I'm trying to, how do you say it? I mean, we're trying to analyze the data and see what is causing
Mhm.
it. But every time either people leave or we don't have the right tools. If we find out where that burst of radiation came from, which was seen by the astronauts with their X-ray instrument, I'm basically trying to find out and then do the interpretation. And for that, I need all the information how the X-ray instrument worked. If I can solve that issue, then I would be happy and I can retire.
You've got and you have one of those devices now, right?
Yes, yes. I mean, that's one of the astroarchaeological things I did. At some point I got way of that X-ray. I mean, a prototype of that X-ray instrument, because I wanted to know how it functioned and how it recorded the X-rays. So I got it by accident because they wanted to throw it away. I mean, I said I mentioned it before. There was this company which moved places. They were the Cambridge, and they also dumped some of their hardware into the dungeon. And a couple of years ago, somebody from NASA came there and made inventorize what was still there, and they said, "We want to get rid of this X-ray, this instrument." And then the guy I was in contact with, he said, "They want to get rid of it. Do you want it because you're interested and want to know more about the instrument?" I said, "Of course, yes." And then they shipped it to Aztec, to Noordwijk, and it's now in the Space Expo.
God.
And we got to do our measurements of that instrument and see how it worked and got a response. And yeah, I mean,
It's just so funny that we have to reverse engineer this stuff that's
yes.
not even that
Oh,
old. Like, it's only
it's
what, this is 70s, 60s?
70s. Yes. 1970. Well, the hardware is of course from the 60s. I mean, they started to build the instrument already in the
Mm,
60s.
mm.
Yes, reverse engineering, and they didn't have any description in the huge archives at Fort Worth. I mean, these are huge buildings with millions of documents. I mean, kilometers or miles high paper, and there was nothing there. I mean, I spent a day wading through documents. I mean, that's already an experience. So you put in this small room, and then there is a trolley with the documents you ask for, and then you flick through them, you make photographs and stuff. And I even found a document where somebody, so at some point there was a problem on board Apollo 15. So then they called the engineers in, and they rush in, they park their car, they run to the command room, and then they start discussing things. And then they had to work overnight. But apparently, one of the engineers, he had parked at the wrong spot of somebody else. So he wrote a memo, an official memo, explaining that he parked at the wrong spot. Sorry about it. He made his apologies, and that, I mean, there was an A4
That's
document. It
in
was
the
very
file.
in one of the Apollo 15
But
files.
not the instructions you needed for this
No,
device. Wow. Is it? Do you think is it possible it's just being misfiled somewhere, or you just think it literally just doesn't
no.
exist?
It, uh, I mean, this is only of interest to the scientists, and so only the scientists who used the data at that time probably had the description. I mean, and all the calibration and how the instrument worked. But when they retire or the institute moves, you throw away the paper.
God, that's amazing. I mean, that's not the case now, is it?
No, I mean, well, we tend to nowadays we archive everything.
Mm. I guess we've
I mean,
also got a
every
different perspective on data than we did before as well.
yeah, yeah, yeah.
Like we realized the value of it. I don't think we did back in the 60s and
I
70s.
mean, recorded and filed, and everything you say can and will be used against you in the court
There
of
you
law.
go. There was another question here. Could you fashion a solar sail? This is from Sat Tracer again. Could you fashion a solar sail that processed both alpha and beta background radiation particles to generate substantial power? Man, these questions are amazing.
Well, I mean, people of agencies love to use solar power because that's cheap. Well, I mean, it's almost for free, I would say, but you don't go fast. I mean, you don't get a lot of power from solar radiation.
And of course, the problem with the energy thing is also like, how do you slow down when you get where you want to get to, too, right? Which is something I'd never considered.
Well, you're already far away from the sun. You don't get much solar radiation.
True.
So
Good point. Yep. It is amazing the length of time these things exist, though. Like the fact that the Voyagers are still out there,
oh
it's extraordinary.
well, I mean the fact that they are beyond the rim of our solar system, but also the fact that we can still communicate with. I mean, it's a tiny spot somewhere on the sky, and you have to direct the commands to the satellite, but it also has to transmit back the information you want. I mean, that's yeah.
I mean, I don't know how you have the patience for this. Like the lengths of time that we're dealing with on a lot of like even just like planning a mission and stuff. Like what's the lifetime for a mission?
Well, that depends on the mission and also the wavelengths. X-ray missions, they last long. I mean, the instruments themselves are very sturdy and they are built to detect also high energy radiation, so they also are protected against high radiation. I mean, if a burst of high radiation comes in, they just record it basically. But if you are looking in the infrared or optical, I mean, these instruments, they are sensitive to this kind of radiation, so they deteriorate. So yeah, so these missions, they last a couple of years,
Hmm.
and there, the instruments need to be cooled because to get more sensitive, you need very cool. The instruments need to be in a very cool environment, and the fuel or the energy to do that, I mean, that doesn't last that long. I mean, then you're talking about a year or a couple of years.
It is extraordinary, even just that. So like the missions are lasting 2 years, but how long does it take to plan them?
Oh, decades. Oh yes.
It's why I
I
can't get
mean,
over that. Like that is
well,
extraordinary.
what what amazed me, I mean, I think the project I'm working on now, they were thinking about that already in the 60s, 70s. So
Wow.
that's 20, 30 years before it flies. I mean, I was surprised when I was in the Fort Worth, so in the archives of NASA, I found documents about the space shuttle. So they were thinking about that already in the 60s. And the first flight was in the I think in
I
'82 or
remember it
something like
well.
that.
Yeah, that was a big thing.
So, 20 years before, yeah, it's not a big deal. Yeah.
And the technology, that's what I find so funny as well, is because by the time these things get up there, the technology's moved on.
Oh yes. Yeah. I mean, they flew wires on the Apollo missions, and
Wasn't it like coiled magnetic
yeah,
storage and stuff?
yes, yes.
Yeah, that
These were the computers. So you're
that's
muted
right.
again.
Someone said that it was like 72K that they had. They had
Oh,
72K to work with.
yeah.
Yeah.
I mean, I think the computer they called was D-Sky,
Mm,
and I think it was a couple of
yeah.
kilobytes.
It
Yes,
is, yeah.
but you can do a lot. I mean, if you are a computer nerd, you can do a lot on.
Well, you had to. Oh, I mean,
Yeah.
you had to do a lot, right? Like you had to work within those constraints.
Oh, I mean, when I was working at the Space Research Organization in Utrecht, I mean, I heard that some people could even program printers. I mean, printers had a memory of kilobytes, but you can program, do nice programs on
I
printers.
always
I mean,
wished I could do that. Like using assembly. Did you ever do assembly language? Because
oh,
that stuff, oh man.
Fortran is the only. Sorry,
Old man Fortran.
yeah, do this and do that. Yeah.
Darth Piram has a question about are there other organizations you work with? Is it just ESA, or ESA has a number of other sort of is connected to other agencies as well, though, right? It's giving up. It's ESA's network has given up on us. Uh, hello.
Maybe that was a sign that we should
We've
try to.
exhausted, yeah, we've exhausted ESA's network. But are there other organizations that ESA works with? Just to finish up that one.
We do missions with NASA, with Japanese. I have been working on a mission with the Chinese, for example, an X-ray mission. Yeah, I mean there are space organizations on a country level. Yeah,
Well,
so
Canada is now is an associate member of the
yeah,
of ESA now
yeah,
too, right?
yeah, yeah, exactly. No, we're dealing with all kinds of space agencies. Yes, I mean we
Look,
do our,
and
but we collaborate with other agencies. Yes, it's a global
I'll
thing.
throw this in too as well. Is
Yeah.
if you get a chance to visit on these open days, you should do it. It like if you
Oh
really
yes,
want to get a sense of what's going on, I mean, there's open days at all the different ESA
yes,
set. Yeah,
but yes, basically they nowadays have open days at every site. Yes, so at least I know near Madrid, the one in Noordwijk, so that's near Amsterdam, basically, and also at the headquarters in Paris. Yes.
and it's extraordinary. If you've got any interest, or you've got a kid who's got any interest in it, or
Oh,
you are a kid at heart who's got an
definitely.
interest in it,
Yeah.
it's brilliant. Yeah, absolutely brilliant. And you'll get a sense of all the different countries that
Oh,
are
it's a
involved.
breadth of things going on. I mean, from engineering to science to research, physics, even
Even
mathematics.
science communications too. Science
Oh,
communication stuff is great.
oh, I mean, that's another side of ESA, which is also very important. As we said, I mean, space politics, it's in its infancy. I mean, we need to, and also when we talk to other agencies, I mean, you have to have the right political speech. I mean, if you say something, if you just say something in English, I mean, they can interpret it differently. So you have to speak the right language to each other. It's
I love that it forces you to see things from the whole nature of science is about seeing things from different perspectives. And that is just helped by having lots of people from different
oh,
places.
I mean, it's not only doing science from physics, but it's talking philosophy, talking politics, talking engineers to compute. How do you call it? Yeah, computer guy people.
Yeah.
Yeah, it's all getting together when you do astrophysics. Yes.
Mm. And it's funny. It's one of the and it's also one of the skills that we're seeing with the astronauts as well, is the ability to get along with people is a big
Yeah.
part of
Oh,
all of that.
I mean, especially if you have been up into space, you need to be very communicative. That's something we scientists not really learn. I mean, only when you getting exposed to it, you start to learn the hard thing. Yeah.
Well, that was it. They went through a phase where it was all like, it was all jet fighter pilots, and then it
Oh,
became. Then they tried all
right.
scientists, and of course they didn't
Yeah.
get along.
I'm flying. Yes.
F yeah, we're flying rocket
Yeah.
ships.
Yeah.
Yeah, it's changed quite a bit.
No,
Um,
no, fly that. Yeah. My thing. Yes. Yes.
yeah, yeah. Well, look.
When Armstrong went down to the moon,
Mm.
I mean, his thing, and did not listen to the commands of NASA. I mean, beforehand, that they knew where they were going to land, but no, Armstrong did his thing. He flew until he had almost no fuel left, and he wanted to go to a spot which was flat and you could land. He did his thing. I mean, nowadays you wouldn't do that anymore. You
Which is
would listen.
probably a good thing.
At that time, it was probably a good thing because you could have landed into a trough or whatever. And
Yeah, he didn't like the look of it, did he? He didn't like where he was headed.
no, no, exactly. And I mean, at ground control, they were sweating like hell. Yes.
And it's funny because one of the issues that they've had with a lot of these new landers has been that they've landed and then fallen over
Yeah. Yeah. I
because
mean,
they didn't know there was
I
something
mean,
there.
that's one of the things astronauts would be are useful. I mean, you're there, and you see where you're going to. I mean, if you do that from remote from Earth, I mean, you have this delay in getting the signal back. So if you're heading towards a mountain or whatever or a trough, you do. I mean, at the
You don't have
time,
time to ask.
no, exactly, yes,
Well, which is again, this is one of the reasons why the autonomous stuff is so fascinating to me
oh,
too. The fact that it's able to work this stuff out in a way
yeah,
that a human could,
yeah, yeah,
possibly faster.
yes,
But yeah, I do love the idea. Yeah, the fact I love that's a perfect example though of like of the science and then the instinct as well coming in
yeah.
as well.
Oh, it's
So yeah.
human
Um,
interaction.
I'm gonna wrap this up
Yeah.
because I've got to go see my mom.
Oh,
Yeah,
yeah.
yeah, at some
Well,
point this afternoon. So
yeah,
anyways, but yeah.
yeah.
But
Oh,
Erik,
you
this
can
is amazing.
you can make her enthusiastic about all the things we talked about.
You know what? Knowing her, she's probably listening.
Oh,
I have to say thanks to Cal too, because Cal's been in here helping out with the modding, and that's yeah, much appreciated. Lovely
okay.
Cal.
Oh,
So Erik, how do people get in touch with you, or do you not want them to get in touch with you, or how do they keep track of what's going on with you?
well, they probably can find me on the internet. I mean, I also have, well, when you're a famous actor or a famous astrophysicist, they will find you anyway. Well,
What is your choice of what is your sort of your location of choice on the interwebs?
well, they can find me through Twitter. I mean, you
Okay.
posted on Instagram, the Twitter account, I think. So,
Oh, did I? Okay, yeah.
uh,
I get so confused with all these social media things. It drives me
yes,
crazy.
yeah, yeah. I mean, you could have attracted much more people when you use more multimedia advertisements. Yes.
Yes, exactly, and that's something that Agne is always bothering me about. But I see. My thing is, I just want to get into the chat. But yeah, so we
Yeah.
got and I sent it. I did also. If people want to sign up for the email of awesomeness on techbandits.org, I sent out a little email about that last
Yeah.
night. So there's like
No,
1,200 people on that'll get that.
I mean, they can find me also on the internet anyway. So
Okay,
Google is
perfect. Perfect. Google is your friend. Use your
yeah,
Google foo.
yeah.
Erik, thank you so much. It was it's just such a joy to talk to you. I now miss. I want to be back in the Netherlands, hanging out with you at bars. You know,
Well,
like,
I we may invite you again. Yes.
oh, I'm coming whether I'm invited or not. Frankly, I'm showing
Oh,
up, even if it's just as a guest.
No, 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 and people should come to the Space Expo and see all the nice stuff we have there about everything
Yeah.
ESA does, and also the X-ray instrument and anything. Maybe we should do another podcast and talk about so many other things.
I'd love to. Look, I'll have you back whenever I can. This is a delight, absolute delight.
Yeah,
I mean, you know, thank you so much.
yeah,
Okay, so everyone, I think yes, a huge thank you to everyone for the questions. It's been amazing. Again, to Cal for doing the moderating, and of course Agne for hooking us up in the first place.
yeah,
So enjoy your holiday,
yeah.
Agne. Enjoy your
And
wonderful 2 weeks away.
you enjoyed the acting.
I shall
Yeah,
indeed.
yeah,
Yes, yes. There's
yeah,
some, yeah, having some acting fun right now. It's true.
yes.
And we'll, yeah, we'll figure out another time to talk because I'd love to come back and we could
Good.
sort of maybe focus in on something in particular if you want.
Sometime our paths will cross.
Yeah. And say hi to your son for me. I had a nice chat with him at the
Yes,
ESA.
yes,
Yeah,
yeah.
yeah.
I to my whole family because I mentioned to all of them about you, and
Oh, great.
yeah. So now we have to see the movies you're in.
No, you
So
really don't. You
no,
really
okay,
don't. No.
okay. No, thanks for your for
Thanks, everybody. Thank you so much. I'm going to
okay,
end our stream now. So until we geek again, I'll say be brave, be kind, be brilliant, cheerio, and
yes.
huzzah.
Bye bye.